Okay guys, this is station 1 and here is the goal sheet. Today we are going to be doing graphing linear inequalities on the coordinate plane. So I want to remind you how to graph an equation on the coordinate plane. If you recall, we used the formula y equals mx plus b, and remember b is the y-intercept and m is the slope. You're always going to want to start first with the y-intercept and then rise and run the slope. So when you look at this equation here, we can see that our y-intercept is a positive 4. So I'm going to put a positive 4 on my graph. Then I need to do my rise over my run. And in this case, it is rise 1, run 2. So we're going up 1, running 2, up 1, running 2. To go in the opposite direction, we would do the negative of each. So down 1 and negative 2, or left 2, down 1, negative 2. And then we can connect those dots with a nice line. So that's how you graph an equation. Alright, do you think inequalities will be exactly the same, similar, or different? What do you think? If I was asking you to graph y is greater than 1/2 x plus 4, where do you think the solutions would be? Well, it's actually pretty simple. All you have to do is graph it as if it's an equation, and then look at the symbol. It says that y is greater. So where are the y values? Well, they're on the axis, right? Those are our y values. So where are the y values greater than where the line is? Above it. Okay? So anything above that line has a y value that's greater than 1/2 x plus 4. All right, so let's do a real example. There's actually one other thing that you have to take into consideration, and that has to do with the boundary. You're going to use a solid line when the inequality contains an equal sign. That's just like when we fill in the dot when we're graphing it, okay? And you're going to use a dashed line when the inequality contains less than or greater than without the equal sign. So let's try one. We've got our y-intercept, which is a positive 2. And then we've got our slope, which is 3. And remember, that can be 3 over 1. So I'm rising 3, running 1. Or falling 3, running left 1. And you really need to extend this to cover the entire space of the graph, because that's what we need to use to show the entire solution. Now look at our inequality symbol. What do we have? Do we have an equal sign? No. So we're going to use a dashed line to connect those. That means that it can't be equal to anything on the line. Then what does that say? Does that say less than or greater than? It says less than. So go to the y-intercept, and we're going to shade the area less than or below the y-intercept. So all of this gets shaded. So that means that any coordinate pair in that entire area, for example, the coordinate pair 1, 2, 2, 1, write it backwards, would be a possible solution. I could plug in a 2 for x and a 1 for y. So it would be y is less than 3 times 2 plus 2. Is y less than 6 plus 2, 8? Yes. So that's why this area down here is shaded, because it could be a solution. Any point in that whole area can be a solution. All right, let's graph a little harder one. We've got x is greater than 4. If you guys recall the little mnemonic trick that I taught you, oy vooks, is this going to be a horizontal line or a vertical line? If you said vertical, you're right. Okay? So it's going through the point 4 on the x-axis. It's going to be vertical. Now this is when it's tricky to tell where we should shade. Oop, I just saw a mistake. What kind of line should I have there? It should be dotted. All right, I'm going to use a different color, make it easier to do dotted line. There's my dotted line. Okay, so like I was saying, this makes it really hard to decide where to shade. It says x is greater than 4. So you need to think about where are the x values greater than 4? They're over here. And again, we could test it. There's a really nice point that's easy to test, and that's 0, 0. That's always going to be really easy to test. And so we want 0 to 0 to be wrong. So we need to put the x value in for x. 0 is greater than 4. Is that true or false? That's false. So we shaded in the correct direction. Anything near this guy is going to be wrong. All right, let's try a couple more. All right, let's do 4x plus y is less than or equal to 2. This one's harder to graph. Can anybody tell me why? Well, we have to rewrite it so that the y is alone so that we can graph it first. So that's going to give me, subtracting 4x from both sides, I'm going to get y is less than or equal to 2 minus 4x. Now your slope is -4, and your y-intercept is 2. So now it's a lot easier to graph. So let's go to that point, 2. On the y-axis, there's our dot. And then we're going to go down 4 over 1. Down 4 over 1. Remember to fill that whole space. It makes your life a lot easier when you're trying to define the boundary. Rise 1, run 4, rise 1, run 4. Okay, now we connect that with what kind of line? Dotted or solid? Well, you've got an equal sign, so it needs to be a solid line. Wow, that's not very straight. Okay, now it says y is less than or equal to. So there's the y. Anything below it, anything below is going to be a possible solution. All right. I'm going to skip that last example. I think you guys are getting the hang of this. So your homework, just 6 problems. Graph them in your notebook and make sure you show any work if you need to. Notice number 3 and number 6, you need to do some rewriting. Everything else will be pretty easy.